Hello and welcome again to ME330 Computational Tools. I'm Harris von Lockett, your instructor for this course. And today we're going to be talking about the packages that are available in SOLIDWORKS. There are a handful of them that you can actually get through different SOLIDWORKS licenses, and we'll talk through the ones that are going to be most important to us and mention some others. So, as we talked about in our last lecture, SOLIDWORKS is a simulation package. It performs finite element analysis along with CAD design. It's primarily known for the CAD aspect of it, but people are now finding that yes, SOLIDWORKS does do FEA, and it does it pretty well. So, when you look at SOLIDWORKS' website, you can see that there's a lot of different packages they have. They've got static analysis, time-based analysis, fatigue, composites, linear dynamic analysis, nonlinear materials, lots of things that you can actually do. However, as with any sort of software licensing issues, they actually want to make some money. So one of the ways that they make money is they partition which SOLIDWORKS packages are available to you based on the type of license you have. So at the lowest level, you've got SOLIDWORKS 3D CAD Premium. Oddly, it's their premium license, but it only comes with the linear static modules, so you can do static analysis problems, and some time-based motion problems where you can have a little bit of movement in your models. If you have the SOLIDWORKS standard package, which does not sort of follow a naming convention that you might think, premium has less than standard, but the SOLIDWORKS standard package adds fatigue and also this thing they call a trend tracker, so you can look at how your model varies with certain parameters that you can input. If you move up to the SOLIDWORKS Simulation Professional, that one adds a frequency domain analysis, thermal analysis, drop testing, so you can look at impact loads, if things are falling, if things are getting struck. You can look at a buckling analysis, so the mode shapes of beams and frames and structures of that sense. Optimization, which is actually getting to be really big nowadays. Imagine if you just take a block of material and then you apply some boundary conditions to it, and then you apply some constraints or some targets that you want, how much load it should have or what safety factor it should have based on the boundary conditions, and it will solve the problem for you, calculate all your stresses, calculate your safety factor, and then automatically begin changing your design such that your design achieves your desired outputs in terms of safety factors, but maybe you're trying to reduce weight, or maybe you're trying to modify the shape to fix some target shape value or something like that, but it'll do that optimization for you. Then there's pressure vessel analyses, ASMEs, boiler codes. You don't have to do these by hand anymore. You can have a module in SOLIDWORKS that'll do it for you. And these packages make it possible for a designer to really take their ideas and run them through almost any sort of conceivable type of, application space that they can think of, real world normal applications for product development, and generate solutions, test those solutions, and like we said before, to try and improve those solutions, prototyping them virtually before you're moving ahead. And finally, if you have SOLIDWORKS Simulation Premium, you really have the highest end that SOLIDWORKS offers. Here, you can not just use linear materials, you can use nonlinear materials for nonlinear statics, you can use composite material models as well. You can also begin to do some dynamic analyses, linear and nonlinear dynamics. So you can have the really full-blown, complete physics of the mechanics-based types approaches that involve moving bodies and whatnot. So in this course, you'll learn how to perform structural analysis on SOLIDWORKS, and that's this section of the course. In the back half of the class, you'll learn the thermal analysis and the fluid analysis as well. We'll do this on parts, and we'll also do this on assembly, so you can get closer to sort of like a real-world design. So if you open up SOLIDWORKS and you look at some of the packages that they have, we can compare, like I said, across the premium, the standard, the professional, and then the simulation premium to see what's actually available. If you go to their website, you'll get this large breakdown of the individual packages. But if you zoom in on some of this, the finite element analysis part of it, we can see that we can do the FEA, but we'll also eventually in this class even deal with contact problems, that we can have two bodies moving either away from each other and then coming into contact with each other on some part of a cycle, or if one thing's impinging on another one. And then post-processing, that's really going to be the thing that gets us our results. And then near the end, we'll deal with the linear static simulation for an assembly where we're putting more than one thing together. There's a pliers type problem that we're doing. And eventually, you might want to look into the design comparison studies where you're doing parametric analysis or fatigue, where something's being operated on or cycling through its use over and over again. We're not going to deal with that here, but those things are available to you. If you delve down further into the finite element analysis, what you'll find is that within FEA, there are several different types of complexities that are available to you to apply to your model. These include different types of elements, so solids, shells, and beams. We'll talk about what those mean. H and P adaptive element types. So this is getting into the numerics a little bit, how precise you want the solutions to be, or in mathematics speak, to what order do you want your solutions to go. Mesh control, how finely do you want to break this up into small pieces and parts, and then some other mesh diagnostics and some customizable materials, and lots of things that are sort of a little bit beyond what we're going to talk about in this class, but that can be important to you and that aren't so far beyond what we're going to deal with, and you should have at least the familiarity with SolidWorks such that if you want to go into these on your own, you can begin to apply those different packages. All right, so for this particular class, we're going to deal primarily, like I said, with the top left corner here. For flow simulation, in the back half, you'll go through this concurrent engineering section, and then we'll deal with post-processing, how you communicate your results, design comparison studies a little bit, where we're looking at the parametric solutions, where we have different parameters that can vary. We want to see how that changes our results. And then the fluid flow and the thermal bit are really the meat of the matter for this section, where you're going to look at the CFD portion, how we can actually look at the boundary conditions for flow, so input pressures and input velocities, and then a flow profile that's generated by some geometry that the material or our fluid is flowing through. And then we can look at that in addition to thermal studies. So if we want to do some heat transfer, if our fluid is changing temperature, and as things get warmer, the viscosity changes as well. All right, well, hopefully we've given you an overview of the SolidWorks packages that are available, showed you the breadth of what SolidWorks can actually do. And one of the things I didn't mention is that the university license gets you access to all of the SolidWorks packages, the entire suite. So we're going to go over some of those tools in the class this semester, some of those packages, but not all of them. But what I encourage you to do is when you get into some design projects or maybe even projects outside of this class for other courses, see if you think, hey, this package could work for this problem. Pick it up, see if you can find some tutorials on it. You'll already have a basis in SolidWorks, and hopefully, you'll be able to apply these methods to these other real-world or closer to real-world problems. All right, thank you very much, and I look forward to seeing you in the next lecture. And that one will cover how you actually access SolidWorks through the university's VDI system. Thanks for watching. Take care. See you next time.